let's use techniques from calculus to help us graph functions. This is going to be a function that you know how to graph from algebra. In fact, maybe we'll graph it both ways. First, using only algebra techniques, but then showing how calculus can help speed up the process. So from your days in algebra, you know that f of x is going to be a concave up parabola. So it's going to look something like this. And it factors as x minus 7, x minus 1. So it's going to have zeros at positive 1 and positive 7. So just a rough sketch. Oh, we also know it has that y-intercept of 7. All right. And we could also figure out where the minimum is, right? Does it do this or does it do this? What happens? So you know that the minimum or maximum of a parabola or a quadratic function happens at minus b over 2a. So applied to this problem, we have an 8 over a 2 times a 1 or a 4. So when x is equal to 4, we're going to have a minimum. And to figure out where that minimum happens, we can plug in 4 into our function. And if you plug in 4 here into this function, I'm going to skip the algebra. Double check me, though. You get a minus 9. All right, so we're down here. Okay, so let's also show that we get this graph if we use techniques from calculus. So first, considering the function, calculus or the derivatives tell us how the function changes, but we don't know where the function should exist. So here, I really think it is best practice to factor that, just like we did before, and observe that the roots occur at 1 and 7. But using calculus, you can find the derivative as 2x minus 8. So these are going to be the slopes to my function. These are going to be the slopes of the tangent lines. And notice that this derivative is a straight line. So it's going to exist everywhere. So my function is going to be smooth and have a nice tangent line everywhere. And we can figure out when it's going to be 0 or when we're going to have a horizontal tangent line by solving for x. And we find that it's equal to 4. So we got the exact same thing up here. We knew that the minimum down here was going to happen when x was equal to 4. Momentarily, we have a horizontal tangent line.